And here we go with section 3.3, finding more derivatives. However, we will go into a few more rules, such as, remember last week I said you need to use this limit definition. Well, now we get to do other rules, other shortcuts that we can do. Now there are lots of new rules here, and I will be writing down, well, I can write it all down, but I think if you listen to what is being said, it will make a whole lot more sense. So here we go. Number 1, y equals 4x to the 4th plus 7x cubed plus 5. And technically, up until this point, we should have been using the limit definition. So be thankful that I have given you some of the shortcuts already. The shortcut for this one, we already know. This is where we take the exponents and multiply by the coefficients and stuff like that. So y prime would become, I'm going to take this 4 times the 4, and that's 16. 16x to the 3rd, because I'm going to subtract 1 from that exponent there. The next problem, I'm going to take 3 times the 7 is 21. 21x, and then I'm going to take the 3 and subtract 1 from it and get a 2. Then I look at this. This is a constant. There's no x's, or actually there's an x to the 0 power, but when we take that 0 times there, we get 0. So this is the derivative and the final answer for number 1. Number 2, we started out with w equals z to the negative 2 minus 1 over z. Now the first thing we need to do is we need to make this into a user-friendly form. This is user-friendly already. It's got just the exponent, but we need to rewrite this one over here. So it's going to be z to the negative 2 power minus z to the negative 1 power. Now that's user-friendly, so now we're ready to actually find the derivative, w prime. W prime says take this exponent, multiply by the coefficient, and there's an implied 1, so that's going to be negative 2z, and then subtract 1 from that, we get negative 3. Take negative 1 times the negative 1, that becomes a positive 1, positive z, raised to the, well, once again, subtracting 1 from the negative 1, we get negative 2. Now we don't like the negative exponents, so we're going to rewrite them in their other form. So that's going to become negative 2 over z cubed plus 1 over z squared. And that is the final answer for number 2. Now we get into something a little bit different, and that's problems 3 and 4. 3 and 4 asks for the second derivative. Well, the second derivative means we're going to have to take the derivative of the derivative. But that's not really difficult, just do the exact same rules. I mean, it's the exact same rules in both cases. It's just we're going to take the derivative of the derivative. So we start out with number 3, which is y equals 7x cubed minus 8x squared plus 3. I'll take the first derivative, that's y prime equals, okay, 7 times 3 is 21, 21x squared, because we subtract 1 from it. Now here I'm going to take the 2 times the negative 8 and get negative 16, negative 16x raised to the first power. I'm not going to put that first power, and this is a constant of 3, so we are done there. Now this is the first derivative. The first derivative is y prime equals 21x squared minus 16x. Now to do the second derivative, we're going to do y double prime. We put the 2 marks, which indicates the second derivative. So realize it could ask what's the second derivative, or it could say find y double prime. So we're going to do the same thing, but we're going to use this one now. 21 times 2 is 42. 42x raised to the first power, because I'm going to take 2 and subtract 1 from it. Now here I'm going to take the 1 that's implied here. 1 times negative 16 is negative 16. Subtract 1 from the exponent, so that becomes x to the 0, or 1. And so it becomes 42x minus 16. The second derivative, y double prime, equals 42x minus 16. Number 4 is same directions, different problem. W equals z to the negative 3 minus 1 over z. First thing we are going to do is to just rewrite this in a user-friendly form. Z to the negative 3 minus z to the negative 1. And realize we haven't taken any derivative yet. Now we're going to take the first derivative. W prime would be negative 3 times 1 is negative 3. Negative 3z raised to the negative 4th power, because I'm going to subtract 1 from that. Then I'm going to take the negative 1 times the negative 1, becomes positive 1, positive z to the negative 2 power. Now normally if we were done, we would write this in its other acceptable, more acceptable form. But we need to find the second derivative. And realize if we would change it to its more acceptable form, then we'd have to turn it right back to this more user-friendly form. So why do that part? Instead, I'm going to take the negative 3 times the negative 4 and get positive 12. 12z to the negative 5th power, because I'm going to take the negative 4, subtract 1 from it. Then I'm going to take the positive 1 times the negative 2 and get negative 2z. Subtracting 1 from negative 2, we get negative 3. Now this is our final answer, except we don't like these negative exponents, so I'm going to rewrite it without those, and it becomes 12 over z to the 5th minus 2 over z cubed. So far we really haven't done anything that you wouldn't be able to have done in the past. Okay, so now we're ready for 5 and 6. There are two special rules for finding derivatives. Well, two extra ones that we're going to learn today, and that is the product rule and the quotient rule. The product rule is used in cases where the derivative are two polynomials being multiplied together, such as this case. Y equals this polynomial times this polynomial, and realize what we could do is we could actually multiply this all out. X squared times this, times this, times this, negative 5x times this, times this, times this, 2 times this, times this, times this, combine like terms, and then take the derivative of it. That's one way to do it. The other way to do it is to actually use the product rule. Now, like I said, I could write out the official technical product rule for you, but instead listen to what it is. What the product rule says is leave the first polynomial alone. Times the derivative of the second polynomial. And we can do the second derivative pretty quickly. 5 times 3 is 15. Subtract 1, we get x squared. Take the derivative of this, negative 1 times the 2 is negative 2x. Subtract 1 from the 2 and we get 1. And this is going to become 0. So that's part of it. Leave the first one alone times the derivative of the second, plus the derivative of the first. So now it's the derivative of the first, so that's going to be 1 times 2 is 2x. Subtract 1 from the 2 to get 1. Negative 5 times 1 is negative 5, and that becomes negative 5 because the x is going to become x to the 0, and this is a constant, so it stays all the same. And then leave the second one alone. Now, as it turns out, this is going to be quite a mess either way, whether we would have multiplied it right off the bat or if we would have used the product rule. But we do need to get to know the product rule because the product rule is necessary in some and in fact many instances. So we have a lot of cleaning up to do here. But once again, the product rule is leave the first one alone times the derivative of the second plus the derivative of the first times the second one left alone. That's all the product rule says. Okay, so now what we're going to have to do is we're going to have to take this and multiply it together. So I'm going to take 15x squared times everything here. So that becomes 15x to the fourth minus 75x cubed plus 30x squared. Then I'm going to take negative 2x times everything here. So that'd be negative 2x cubed plus 10x squared minus 4x plus. Now I'm going to have to take this whole thing and multiply everything out here. I'm going to take 2x times everything here. 2x times that would be 10x to the fourth minus 2x cubed plus 10x, and then take negative 5 times everything here, and we get negative 25x cubed positive 5x squared minus 25. And then we get the joy of combining all these like terms. So I'm going to take 15x to the fourth plus 10x to the fourth and get 25x to the fourth. Now I'm going to look for my x cubes. Negative 75x cubed, negative 2x cubed, so that's negative 77. Another negative 2, so that's negative 79. And another negative 25, so that's a negative 104. Negative 104x cubed. Now I'm going to look for my x squareds. 30 plus 10 is 40. Plus 5 is 45. So 45x squared. Now I'm just going to look for my x's. Negative 4. Positive 10 makes a positive 6, and that looks like all there, so plus 6. And then my constants, I think I might only have one. That's that minus 25. And so in the overall scheme of things, we've got this mess. Yes, this was messy. This would have been almost just as messy. And then you would have to take the derivative, but you would have ended up with this answer just the same. Now, let's take a look at what number 6 has to offer. Number 6, y equals 1 over x squared plus 6 times x squared minus 1 over x squared plus 6. Now the first thing I need to do is I need to rewrite this in user-friendly form. So I'm going to write this as x to the negative 2 plus 6 times x squared minus x to the negative 2 plus 6. So this is my user-friendly form. Let's use the product rule, although this case, more than likely, I would probably just multiply this out and then find the derivative of that. But that's, since you've only had one example of the product rule, let's do the product rule again. So y prime will be, leave the first one alone, times the derivative of the second. Well, the derivative of this would be 1 times 2, or 2x to the first power. Negative 1 times negative 2 is plus 2x. Subtract 1 from that and you get negative 3. Plus 6 is a constant, so that's 0. So I have that. Then it's plus the derivative of the first. Well, the derivative of this is 1 times negative 2, or negative 2x to the negative third, plus 0. So see, it actually becomes a monomial, so in this case it might be even actually a little bit easier, but leave the second one alone now. X squared minus x to the negative 2 plus 6. Now we have quite a bit of cleaning up to do. I'm going to take x to the negative 2 times everything here. So x to the negative 2 times the 2x will become 2x to the negative 1. This times this would be plus 2x to the negative 5. Then I have to take 6 times everything here. So that would be plus 12x plus 12x to the negative 3. Plus, now, here, this is just a distribution. I need to take negative 2x to the negative 3 times everything here. So that's going to become a negative 2x to the negative 1. A positive 2x to the negative 5. And a negative 12x to the negative 3. Now we're just going to put them in order. Let's put them in order from biggest to least. And let's see, the biggest exponent I have is a 1. And that's the 12x. So I'm going to put the 12x first. Then it looks like the next biggest exponent is negative 1. So I have 2x to the negative 1 and a negative 2x to the negative 1. They actually cancel each other out. So then x to the negative 1's cancel each other out. Then the next biggest is the x to the negative 3. Well, 12x to the negative 3 minus 12x to the negative 3, those cancel each other out. Wow, this is turning out fairly nice. And then that only leaves the 2x to the negative 5th plus 2x to the negative 5th is 4x to the negative 5th. Now realize why double prime would be super simple if we really needed to do the second derivative. But we don't, so we just need to rewrite this in its more acceptable form, and that would be 12x plus 4 over x to the 5th. And those are the examples for the product rule. Leave the first one alone, derivative of the second, plus derivative of first, leave the second one alone. Now we get to compare that to the quotient rule. Now the quotient rule, there's a whole lot of other stuff that needs to, there's a whole bunch of stuff really that you need to learn. But here's one way to learn it, and it makes you sound really funny, really stupid, but it works. It's Hody Hi minus Heidi Ho over Ho Ho. Okay, Hody Hi minus Heidi Ho over Ho Ho. And you want to remember it this way. First of all, the D means the derivative. Okay, Ho means the denominator. It's a play on low, so it's actually the low d high. So the low, the derivative of the high. Well, if ho or low is the denominator, high is the numerator. So it's the denominator times the derivative of the numerator minus the numerator, the derivative of the denominator. This is the numerator. I can't remember if I said that right. Numerator, denominator of the denominator over ho-ho. Well, this is denominator, denominator. Denominator squared. That's what it amounts to. So that's how you find, that's the quotient rule. Hody Hi minus Heidi Ho over ho-ho. And that's one way you can learn it. Or you can actually get a book and look at all the symbols that are involved. This truly is the easier way to go. So let's look at example number 7, and then we will continue this on the next video, because I am running quite out of time. But, well, actually I've got more time than necessary, but I want to keep these at between 20 and 30 minutes. So we'll stop here after this problem. G of x is equal to x squared plus 5 over x squared plus 6x. So once again, this is high, this is ho, and the d means the derivative of. Okay, so just keep those in mind. Okay, so to find g prime of x, what I need to do is I need ho. Well, ho is the bottom, the low. So it's x squared plus 6x. D high. D means the derivative of the top, the derivative of x squared plus 5. Well, the derivative of x squared plus 5 would be 2x. So this is just a distribution here. Minus high. Well, high is x squared plus 5. D ho. D ho is the derivative of the denominator. Well, the derivative of the denominator would be 2x plus 6 over ho ho. Well, that means low, which means denominator squared. So I'm just going to take x squared plus 6x, the quantity squared. Now here's the nice thing about quotient rules, is that I'm not going to require you to carry this on out. This is perfectly fine the way it is, but I am going to require you to straighten this up. So what we need to do is we need to take 2x and distribute everything here, so that would be 2x cubed plus 12x squared. And then we need to distribute everything here, or this is actually foiling, realizing we have a negative here. So this would be x squared times 2x is 2x cubed, negative 2x cubed. The outer terms would be negative 6x squared. The inner terms would be negative 10x, and the last terms would be negative 30, all over ho ho. And then finally, cleaning everything up here, 2x cubed minus 2x cubed, well, they're gone. 12x squared minus 6x squared leaves 6x squared. Minus 10x minus 30. All over x squared plus 6x, the quantity squared. And there is the derivative. Realize about the only other way to do this, we can't go ahead and do the products because there is no products to be multiplying by, and we certainly can't do the division unless we really wanted to do long division, and I don't think you want to do that. The only other option is to use the limit definition that we looked at last week, and I'm pretty sure you don't want to do that either. So here's how we do it. Ho-de high minus high-de ho over ho ho. Remember that as your quotient rule, and we will finish the rest of the section up in the next video.